everyone, and we're going to talk about reactivity. So hope you are ready. So first of all, my name is Salama Ashoush. I'm a consultant at I/O. I'm also currently working as a full stack engineer at Cadena. And yeah, I like experimenting with a lot of stuff, trying a lot of ideas in different programming language as long as I'm building apps and stuff. So, and I also learn a lot while doing it. And you can find me everywhere with my name, Salama Ashoush. And yeah, this is QR for just a place where we have everything. And then, yeah, today I'm going to mention a lot of frameworks. I just want to disclaimer from the beginning, I love every framework equally, so there will be no fight about which one is better. So I'm just talking about Signal and reactivity in different frameworks. So what is reactivity? So there are a lot of definitions about reactivity. Like if you look at Wikipedia, you might find a lot of reactive programming definitions, talking about like some talking about electrical engineering stuff, some talking about programming stuff, some talking about signaling and voice stuff. But I like this one. Like it's about declaratively express the relationship between values over time, right? And maintaining this relationship as well. So this one from Ryan Carniato, the creator of Solid.js framework. And then the definition from what I said, it's about like if you have an equation like this, C equal A and B, what reactive system, what a reactive framework will do for you is it will keep it alive. It will keep it, maintain the relationship. At any point, C will always have the latest value from this equation. So, and there are different kind of reactive systems. There is one reactive system called like a coarse reactive system where the system itself, when it needs to calculate the reactivity, it has to do a lot of work. Like if you have a, like, let's say an example in React, if you have a big component tree and then you change one thing, then React had to reconcile all the tree again and find out which part did change, and then it will say, change the part in the UI for you. So this is called coarse reactive system. And yeah, nowadays, mainstream frameworks like using this system are React, of course, and Angular, the current version of Angular, and Vue.js. You might argue, yeah, Vue.js does not use this kind of system, but still, since it's using VDOM, it still has this kind of limitation. And there is another kind of reactive system you could have, which is it's called fine-grained reactivity, where when you have a big tree again, and you change one part of the tree, it will go directly to this part and surgically replace the part that you changed. And this is why it's called fine-grained reactivity, because I don't need to do all the work again. I don't need to loop all through the tree again and calculate it to just find this small part that has changed. And currently, there's Solid.js, of course, one framework that implements this way, and it's failed. There is an asterisk about Svelte in this one because it does it currently with differently than it will be in the future. We will talk about it. And then there is Quick, and there is also Angular that currently they have Angular Signal. You can use it in V16, I guess, but it's still not fully implemented. The rendering system is still not fine-grained reactivity. So we are talking about different kind of reactivity. And if you look at the reactive system, you can always tell if you have this kind of fundamental stuff, component in a reactive system, you always have something called reactive unit. Sometimes we call it like a wrapper, holder, or subject. Sometimes we call it signal, as we will call it in our talk. And then alongside these wrappers or these units, you always have some way to react when it changes, right? You have a value, and you wrapped it in some reactive wrapper, and then you have reactions about it. Like, for example, sometimes you call it effect, watchers, auto-runs, subscriptions, different between implementations. And then, based on this reaction, you also have a concept of computation, like, or derivations. Like, you have two values, and then you derive a new value based on the old two, or the previous two. Like the equation, we have C equal A plus B. And then there are hidden stuff you don't usually interact with, but they are there to maintain the reactive system, like algorithm, which algorithm it use, like it's push system, ball-based system, or it's hyper. Is it lazy to evaluate the stuff, or it's eager? And does it support concurrent rendering? Does it have a scheduler, and so on? And does it do the dependency tracking? How does it work? You do it by yourself, or the system does it for you, and so on. We will look at different implementation in different framework, and we will see how it's done. Another way to look at reactive system is there are also, you can group them by they run on runtime, or they have a compile time magic that does it for you. So for example, a runtime system, there are two mainstream reactive systems that run at runtime. One of them, probably a lot of people know about it, it's RxJS. And the way it works, like if you have this code and you need to make it reactive, you will have to do like install RxJS, and then you have defining two behavior subjects, and then you use some operators from RxJS to map and model the relationship between these values, right? And then finally you subscribe to this stuff, and up until this point, nothing is happening, right? Until you start pushing, and then the system, the subscription already subscribed to it, and then it starts emitting values for you. And yeah, this is maybe Angular developers know it because it's built in Angular now. And this is, we call it observable, and it's mostly used for a stream of values over time. Like it's not only one value that you need to maintain, but it's a stream of events. Like you could think about one good example is a WebSocket connection that keep emitting new messages for you, right? It's clear to distinguish between this and the next one we will talk about is signals. So in the signal implementation, this is another runtime reactivity system where you can do, it's a simple pub subsystem where you create a wrapper for the value. This is just some random library. It's not specific implementation, just to illustrate an example, right? And then you define two values, wrap them with some wrapper, like let's call it signal now, and then you do some computed stuff like this. You have also some utilities and stuff to do the computation and drive values. And then you have something called effect. Like if we looked at the three components we talked about, like what is a wrapper? It's signal. What is the computed stuff? It's computed thing we have. And what is a reaction? Is the effect thing we have. And then this, it depends on the system. This could be eager. Like it could, when you run the effect, it already have value. It could already console log some value based on the implementation. But yeah, for example, there are some systems that don't emit anything until you just evaluate all the stuff, and then it's lazy, and then you push a new value, and then it will do the work. But some system, for example, like SolidJS, it's eager system. It will do it right away. And then we have the other kind of reactivity, which is done in compile time. And really good example about that, probably most of you know about, is Svelte. So if you have the same example again, if you do it in Svelte, it will be something like this. Nothing will change it. Like it's still regular variables, right? But you have the derivation or computation, it will be like this, like C equal A plus B. And you say, what is this $sign calling thing? What does it do? It actually, it's valid JavaScript code. And if you copy paste it and put it in there, it will be JavaScript code. It will run normally. But this in Svelte, it does some magic. It's not just, in JavaScript, it's just a label. Like if you know go to statement, in old ways, if you work with it, it's just a label. But in Svelte, the compiler will take this thing and convert it to some reactive primitives, right? Nowadays, it's not signal, actually. It's just some code that keeps this value alive, that keeps the relationship alive, but it's not a reactive system. And then when you try to update the value, there is some code also generated for this thing to keep the value updated, and then you use it in a template like this. And this is Svelte today. So there is one important thing you should keep in mind. change detection is not always a reactive system, right? Because you could achieve the same thing with a lot of different ways. Like the perceived reactivity of the UI, like when you do something, the UI update, it could be done by a lot of different ways, right? It could be done by diving, like for example, React. It could be done by dirty check, like old AngularJS. So, and hooks, of course. But yeah, when we talk about change detection, it's not always a reactive system, right? Because some people say, yeah, React is reactive. It has a name in there, right? It's not true, right? At least what we are talking about today is not what React have, right? So we are talking about signal. Let's dive in more to talk about more about signals, right? So in signal-based reactive system, we have, like this chart is really good, right? Because we have a wrapper, as I said, observable state, and then you update it, and then it notifies the derivation values. And then this derivation or the wrapper itself could trigger a side effect. And one of these side effects is rendering something to the screen or to the UI. And then it's really simple and declarative and also composable, right? You could compose a lot of these values together. Let's now dive in more details about like how it's come today. Like Signal is not it's not new. It's like 10 years ago or more than 10 years ago, there was this code. Like, can you guess what code is this? Yeah, of course, it's a QO thing. It's a Knockout.js. Like it was 2010. Like it's like 13 years or something like this, right? And it's what we have. It's what we are talking about today, right? It's signal-based and it's reactive, runtime reactive system. But there was a problem with it. There was a lot of problem with it because Knockout at the same time there was AngularJS also. They introduced some ideas like data binding, two-way data binding. And it's a really cool idea when you have the UI, you link some value in the input to some base of state in your component. It's pretty simple, right? And everything is working magically, right? But then you have a lot of problems with it, right? If you remember in AngularJS days, you used to have this task thing and then flush, and you had to do some, especially with promises and the synchronous stuff. You had to do a lot of manual work to get the system working correctly. And then it's not always, and it was leaking a lot, right? And then shortly after AngularJS, like a couple or 3 years later, then React was invented by Meta or Facebook, right, team. And then they introduced really new concept, right? It allowed you to not do the change detection automatically for you, but they allowed you to, like this, we have a state, and everything else is derived from this state, right? We will not do this two-way data binding for you. We have only one way flow, and you tell us when we need to recalculate, right? And how you tell React when you calculate is by using state, right? Nowadays it's hooks, but before it was like the set state, and it's the same idea. It's just the point where you just run this thing. Now React need to do some work. Before this, nothing need to be done. In AngularJS, there was like a timer or something that always trying to make the template, HTML, up to date with the state. Yeah, as I said, they also introduced a strict one-way data flow, right, where everything is derived from the state. And then React became really popular, and everyone liked it, and they adopted it, right? And then because there was like really simple state management in there, and there was not very opinionated, so it allowed the community to actually introduce new ideas to manage the state. And one of these ideas was Mobix, right? Mobix was really cool because it's also like, you can say it's signal-based thing, and in Twitter or X nowadays, when you talk about signal, a lot of people, yeah, hey, this Mobix has been doing it for years, and they are true, right? But it's still the same system, but there are a lot of changes added to it, right? And Mobix implemented actually a cool idea, which before in Knockout it was like push-based system. They introduced a hybrid system, and later on Vue also implemented similar system. But there was one big problem with this kind of system, which is data leaking, like memory leaking, because they are based on subscriptions, and these subscriptions hold the value, until you manually dispose this value, right? And if you forget it, then you're screwed, right? You're running out of memory if you have a really complex UI. It's also true about the RxJS. How many people now like spend like countless hours debugging how you forget to like to dispose the subscription on ng destroy, right? A lot of people, even utilities to help you do it, right? And then there was this unknown framework library called SVS. So yeah, we have these electrical circuits, and they really work in a synchronization way. They have really cool idea of synchronization. And so why not implement it in the code? And they implemented it. And then they called, it was the first time they called the primitive or the wrapper we're talking about signals. And then later on, SolidJS also implemented it. And one important note there is they introduced the concept of ownership, right? We will talk about it, but its idea is when you have an effect, this effect is owning the disposal and cleaning up of the state, the signals that subscribe to it, right? It will become clear when it was examples later, right? And as I said, Vue took the push-pull thing from Mopix, and then they added to VDOM, and then you have the view. And then, yeah, they have also scheduling and concurrent stuff. So that's why it didn't start like this, but later on they separated the reactive system from the framework itself, and then you have this kind of stuff. So when we talk about, yeah, Vue has signals and stuff, yeah, it's true. They have signals like ref. Ref is actually just another name for a signal, right? And they have, if you look at the three main components we were talking about, ref is the wrapper or the signal, and then computed is the computed values, and then watch effect, or sometimes we will call it auto runs. It's the same idea. But because Vue uses VDOM, that's why it's still not fine-grained reactivity. It's not fine-grained reactive framework. And then SolidJS, yeah, what the Ryan Carniato did is, yeah, this React is really cool. GSX is really cool, and everybody loves it. I will just keep using GSX, but get rid of the VDOM, and then introduce a runtime reactive system. And this is actually what popularized the idea of signals and fine-grained reactivity. Nowadays, if you mention everywhere signals, either you find SolidJS fan like replying, or you find Ryan Carniato himself just helping other frameworks to implement signals. So, yeah. And then, yeah, one of the frameworks was heavily inspired by SolidJS for the reactive system is Quick, right? Quick has the same idea. Even they sometimes use the same name, but instead of create, they use signal. And then they have, yeah, if you look, what is a wrapper is use signal. What is the effect is use visible task, right? And then what is the computed value is they have this use computed thing, right? And then everything works the same. Sometimes there are some frameworks that does sitters and getter, like a.value++, it's a sitter. And sometimes there are like read and write segregation, like in SolidJS and React, when you have like the function to read the value and another function to write to the value. Right. Quick is a bit special because the reactive system itself can be serialized from the server to the client, and then continue where it stopped in the server. This is what the concept of resumability in the first place. So you run everything in the server, and then at some point, yeah, you stop and then serialize everything, all the system to the client, and then you continue. Literally, there is an API called resume, right? You just select an element and then call resume, and then it will continue the execution of the code. And this is unique to Quick. Nobody can do it right now except Quick, right? SolidJS even has a reactive system, but it's not serializable, right? When it still needs hydration in the client. So we talk about different framework, different stuff. Let's implement our own signal-based reactive system. So if I'm gonna implement it, maybe just call it, because I like SolidJS a lot, so I will just call my wrapper create signal, right? and I will use read-write segregation. So I have a read function that has a value, and then I have a write value that sets the value, right? And then I return both of them, right? This is really simple, right? But still, it's not reactive. If you do it like count and stuff, and then you console log, it will work. But because you only like, it's just putting a line underneath each other, and it's working. But I need an effect. I need to I don't need to manually console log every time, right? So let's implement the effect part, right? And if you look, we updated our create signal thing. Now we have a global context, right? And this is just an array, right? And then the first thing we do in the create signal is we create an array of subscription that will subscribe to this signal, right? And then when we read this value of the signal, now we do more work, right? We first look, do we have anything in this global context? If we have something, we pop it from the global context, and then we subscribe to it. Subscription means in here it has two-way subscription, right? I will subscribe to the effect, and then I will add myself to the dependencies of the effect. I will show it to you now. And then when I write the value, this is a subscribe thing which is two-way subscription. Like I push it into subscription, my own subscriptions, the effect that is running currently that I got from the stack, and then I put the subscription itself as dependencies of the effect. And when I write, I just update the value, and then I loop through all the subscriptions, and then execute their subscription function. Execute their subscription there is like an effect thing. I will show it the code for the effect. But if you look, it's actually not that complex. It's a pub subsystem, right? You have a bunch of subscription. When you write to them, you loop through them and execute the handler for it. You could think of it like this. And then, now we have the create effect itself. Like we adapted our create signal. Now we are implementing the effect, right? It's really simple as well, right? First thing, we have a function. We pass a function to the thing. And we have create an inner function called execute, and just execute it right away, right? This is an eager system, right? This is what I was referring to as a lazy and eager system. In this case, my system is eager because I don't do any other stuff. I just, when you use create effect, the function will run right away. And then I create an object running, and this is what I will push to the stack, the global stack, if you remember, right? And then it has the execute function I wrote, and it has its own dependencies, right? And then what I do is, first thing I do is I clean up the previous stuff. We will know why we need to clean up before. Clean up means I will check the running effect, and then remove myself from this effect, and then I will push myself again, and then I will execute, right? And then I will remove the effect from the stack entirely. So I will execute the function, and then I will pop the stack, right? And then let's see it like this is the clean function I told you about. So just a simple thing, looping through the dependencies, and then deleting everything, and clearing the dependencies itself, after all. And then let's go to the example again, right? So we have the same example, but now we have create effect, right? Console.log count is, and then when we set the count, now we have the console.log. I don't have it running, but you can copy paste the code, and it will work for you. And then it will keep updating the value, right? Console.log count is, it will always be latest value. But then how about derivation and memo? If you think about it, memo is actually simple. It's a function that you need to run when some signal did change or not, right? So, and the implementation of it, it's just a signal with an effect, right? Nothing special in there. And then we return the new signal we created. And this is the same code before, but now with more derivation. Like we have this show phone name thing, and we have like phone name itself, which is derivation from first and last name. And then there is one concept in there which is called dynamic tracking, right? If you remember the cleanup function we talked about, It's important here because if we have this code now, like full name, and we have a memo, and we have this condition if we have show last name or not. What happens if we change last name and the show full name is false? Show last name is false. What happens if we change it? Do you think this create memo will run again? It will not, because this is what we mean by dynamic tracking, because it means that because this is a condition, if we show last name and then we set last name, in this case it will, before running the thing, it will clean up all the previous stuff, right? If it was true and then you change it to false, then it runs the first cycle and then it clean up itself from all the effects, and then it will set up again itself. And this time, what runs inside the effect will add it to the stack again. And then because the condition is just a condition, right? If you look, what will be run if it's true, then both of them will run. But if it's false, only first name will run. That's why when you change last name in the beginning, it will not do anything if the condition is false, right? It will not run last name. But if you set it true and then run last name, it will run both of them. This is what is called dynamic tracking, right? And it's done for free, right? In React, you have to, like, how many times you messed up some use effect and you forgot to add something to the dependency array. And probably in most reactive systems, there is nothing called dependency array, unless if they have a way for you to, if you need really advanced stuff to do it. Right, and now we are talking about, like, we talk about signals, it's really cool, but it's not enough on its own, right? It's not enough for me to implement full UI stuff with HTTP calls and all this stuff. Right? That's why we have some wrappers around the idea of signals, right? There is some concept of a store, right? It's like if you work with Redux or something similar idea. You have a full object, and then you need to change one thing, right? And this is unique because when you change, if you have a big object like this in React, and you use state, for example, when you change any key, everywhere the object is used, it will re-render, right? But in this case, it will only render if you use edge, right? Because this is a proxy, and every key in there will be its own signal, right? And then if you subscribe only to edge, this is where you need to do the update, right? This is what is the concept, again, of fine-grained reactivity, right? And there is another version of it which create mutable. If you use state and Redux pattern, you can use the first one. If you like Mobix way or like MRJS way, then you can use a mutable store, right? Which you just update the value directly, and it will trigger the update when it's needed. Similar concept in Quick. They have the same concept, use a store, and then it works the same way. But this way, it just works directly with, it's like getters and setters, right? And it's the same idea. And then, everybody like React query, right? We love it and we do it, right? There's a concept called resources. It's equivalent to React query, but not entirely true because there is no caching, nothing in there. But it's just a way if you need like an asynchronous function, you need to run, and you need to keep track of its state. Like if it's loading, for example, I need to get the data, I need to rerun it again, like HTTP call, for example. And then this is the concept of resources. Like this is how it looks in SolidJS, and this is how it looks in Quick, for example. It's the same idea, even same name, but used instead of create. And then in Quick, there is this extra thing with resource. It's like suspense, right? You give it the resource itself, and then you can say if it's the fallback, if it's loading, then render this. If it's done already, render the other true value, like when it's resolved. Again, this is the asynchronous reactivity. And then we have, working with components, especially in SolidJS. Component is just a function that you wrap the stuff in. It's not, it will never run again, right? And that's why if you have example like this, double count multiplied by 2, it's really a big debate. If you discuss SolidJS, they always complain about this. In React, you expect, every time I update the count, this should be always like reactive, right? It should always have the latest value. But it's not true because if you think about the function, it only runs once. It's just a constructor for the UI, right? And everything later on is wrapped inside the big use effect. And then if you do it like this, it will not be reactive because it's JavaScript, right? You create the variable and then it has a value. And then it's not a signal or a computed thing, right? It won't be reactive. So to make it reactive, you either do like wrap it in a function and then call the function later, or you use create memo in this case. But in Quick, yeah, what do you think will happen? Like it's the same? No, it's not. Because Quick has a magic trick. This one will work. Because in Quick, they are fine-grained reactivity until we cannot do it, right? And this one case that we cannot do fine-grained reactivity. In this case, if in Quick, the compiler actually has some trick, and this code will result to like React does. It will run the function again. It will run the component again. And then this will become always true. It will have the latest value. So we talked about it, and we have a lot of different implementation, and we implemented it ourselves, right? What is happening now in the future, right? If you use React ecosystem, like everybody will wonder, yeah, where is React signals, right? React will never implement signals. They are working in a compiler, React memo or React forget, and then, but there is already some effort from the React team. They have their own version of signals already, and you can use it in React, by the way. But Dan Ambromov is not happy about it because, yeah, the way it was implemented, it has to update some internal stuff in React, and then it messed up with some other packages in the ecosystem. So it's not a good idea to use it. And then there is this thing, right? It happened like a few weeks ago. Svelte team announced that you are working in a new version, which actually has now clearly says there is our state and there is our derived value, and this is the effect, right? The three components we talked about in the presentation, right? And then behind the scene, this called runes. You work like compiler macros, right? You will be replaced by some other code. But behind the scenes, there is actually a real reactive system that in the runtime that has this stuff. And if you look at the code, there is signal thing in there. Even use the signal name. But in the code you write in the component, they call it runes, and this $sign means that it will be compiled out to something else. And it's Angular, right? Someone was asking if I'm talking about Angular. So they have their own version of signals, right? It works the same way. Like you have, now you said you mark the component, you flag it as a signal, it uses signal, and then you have this count thing, and then you update it. There is different implementation, but it works the same way, right? And then, yeah, this is the signal thing, and this is where you update it. And then this is the flag I'm talking about. And then there is, keep in mind, it's actually still used Zone.js. There is nothing, rendering itself is not fine-grained reactivity yet. But you could compose signals, and you could use it alongside Zone.js nowadays. But in the future, they are working also on replacing Zone.js entirely and having a fine-grained reactive system, like similar to Solid.js. And then there are also a lot of utilities around signals. Like, for example, this is an input, right? But as a signal, right? And in Angular, inputs is like a properties thing. You can use inputs, but as a signal, right? And similar idea, right? You can also compose them. And then you also have view children also as a signal, right? This is just what Angular has, the feature it has, but wrapped as a signal in this case. Do you recognize this code? Yeah, it's Rust code, right? So signals and reactive system are not actually a JavaScript thing. It's everywhere, right? You could write the same implementation in a lot of languages. Actually, there are some programming languages that, by nature, they are reactive. And this is actually a Leptos framework, and it's actually like React and Solid.js. It's inspired by Solid.js, but you write Rust code, and then it will compile to WebAssembly, and then you have a reactive UI and the fully reactive system in there. So, and yeah. One last thing I would like to say is Signals is like the new VDOM, right? What I mean by it is like when VDOM came into place, it was like really weird. Why we do this? Like what is this thing, deving and reconciliation and all this stuff? And people were like fighting, should we use it, should we not use it, and so on. signals are kind of the same place right now nowadays. Like signals is not new idea, but it's now become popular again. And then everybody, yeah, why we need to use signal? We have React and it works. Yeah, it will take time, and then eventually it will be adapted by a lot of framework. Not only adapted by a framework, but the platform itself. There are a discussion nowadays that you need to implement in the platform. Like in the browser itself, you will have some signal constructors or primitives, the one we talked about, that you can use without any framework. And that's my talk, right? Thank you.